Hi everyone. I'm Ansab Gillani, and this was supposed to be a recorded video, but yeah, um, I was kind of like late in submitting it. Anyways, I'm gonna present building micro-frontend architectures for scale. Originally, this was supposed to be curated around JavaScript, but I've narrowed it down to just for micro front-end architectures because, in interest of time. So I'll get started on it right away without any um, further time. A little bit about me. I'm Ansab Gilani. I'm a software engineer in one of the biggest organizations based in Pakistan called Arbisoft. And we are actually subcontractors for edX and OpenEdX, which happens to be one of the biggest, uh, provider for LMS and online learning spaces. So anyone who wants to reach out to me, anyone who wants to ask me any relevant questions, you can scan the QR code. You can reach me out on LinkedIn, and yeah, I'll be happy to talk to you. A little bit about our company, a message from our CEO. We are very much, happy to participate in any conferences, and we, hold that uh, essence of sheer determination towards the community, and we want to help the community out. So anyone who wants any help in any project or anything, they can directly reach us out. Coming back to the agenda today, we're going to talk about monolith architectures, microservices, their differences. We're going to talk about building micro frontends. Then we're going to focus on why actually micro frontends work. And lastly, we're going to talk a bit of using case studies for OpenEdX. Okay, starting from monolith and microservices architecture, we are going to discuss what and how each pattern is unique and what exactly is the pattern. Before we actually go into each definition, I'm going to direct your attention towards this Google trend, which is primarily, a difference between how microservices have been in talk for the last decade or so. And it used to be a popular, monoliths used to be a popular method for development, but yeah, eventually microservices just happened to drown them out eventually over time and became so much popular than typical monoliths. So, monolith architecture, what exactly is monolith architecture? Monolith architecture is, in simpler way, a traditional way to build applications. And you just create a single indivisible unit, which has all the client-side UIs, server-side application database, all unified and managed in a single space, in a single server. And it used to be very popular. It is still popular in most projects because it's simple to develop, it's simple to deploy, it's simple to scale, it's simple to test and debug. And it's slowly, I would say, it's very slowly going towards its death because of its like there are so many problems with monolith architectures with large scale products. For example, there's slower development cycles. There are reliability issues. There is barrier to technology adaptations, and of course, there is lack of flexibility. But essentially, these are still a very popular way to develop any application to this day. Microservice architecture, on the other hand, these are collections of small autonomous services inside your whole bigger picture of architecture. Imagine that you have tens of different business cases, and each business case is divided into different services, each having its own capabilities and computation power, and serving it directly from a single server. So that essentially defines a microservice. All these microservices can either communicate synchronously over REST APIs or maybe asynchronously from AMQP. But essentially, all of them are independently and as decoupled as they can be from each other. Um, of course, there are some other things like data consistency, which is maintained by a Saga pattern and stuff. But I'm not gonna go deep into that. Why am I talking about microservices? I mean, like this talk is about microfrontends. So microfrontends is essentially a microservices resembling architecture where each component, each business case is divided into its own front-end architecture. Each is loosely coupled from each other, and it extends the idea of microservices and define it into the front-end architecture. So on the right, you can see a diagram of how different teams like team product, team payment, team search have their own dedicated front ends, each communicating with their dedicated backends and dedicated databases. So all of them are completely separated and secluded with each other. Some industrial examples, Netflix is one of the most popular example. You may have heard of their monolith back in 2007 and 2008. And eventually they were the pioneers of migrations from monolith to microservices, starting from 2009. And right now, to this day, they have over 1,000 different microservices. Similarly, there is Spotify, there is Atlassian, and of course, Amazon. My company, my contractors, OpenEdX, are one of the most famous, organizations to accommodate microservice architectures and micro front-end architectures in general, which is like huge deal for us. So in summary, the difference between both of them is I'll define it three ways. It's a 3D scaling of any application. So there's an x-axis scaling, which is scaled by cloning of different services. You can create different instances of the same server, and what you do is you try to load balance the traffic in between them. Then you can do scale by splitting similar things. You can create similar products, like for example, front end and back end. You can split two of them. Finally, you can split by splitting different things, which is functional decomposition. You define a business case, you identify if that business case is helping you out, and you find that in a separate microservice. So that is essentially how we do a 3D scaling for each server. Why microfrontend works? This is very simple. You have a technology freedom. Imagine that you're building an application made out of React and you're building an app, like you have a singular page built out of React, and then you have another page that you want to build out of Vue. So micro frontends offer you that functionality that's essentially gonna help you make one server out of a React app and the other server out of a Vue app. On the other hand, maybe you could imagine something like an Android development and iOS development, where you can use Kotlin for Android and maybe Swift for iOS. So essentially, it's a very big freedom that you get with using technology. Of course, there is like multiple smaller code bases. You can have smaller engineering products that you can build individually, manage individually, or maybe a team can manage that, but small secluded teams, they don't have to rely on each other. You can have better flexibility. There is lower entry barrier for newer developers. So yeah, everything works out for micro frontends for us. But the main advantage of micro frontend is dedicated frontend. So when I say dedicated frontend, uh, I mean that, like, for example, you're imagining to build a B2B SaaS product where you're expected to create brandings and instances for each customer. Imagine that you're building an application like Shopify. How do you handle that? How do you cater every business that you're creating an instance for them, you're creating a theme for them, you're creating a specific branding for them? The answer is microservice, or rather micro frontend. What you do is you create a front-end template for each customer-facing application. You replicate that for each incoming customer. And all you have to do is you have to edit the theme, you have to edit the styling, and converge all of that in a single instance and just deploy it. It's as easy as deployment. And the main part is you can do as many customizations for each and every different customer as you want. So you don't have to focus on that something is gonna break your system, or some customization for one customer is gonna affect the other customer. So that's one of the biggest advantage of dedicated front ends. Coming to the front end principles, how do you define an architectural principle for a front end? So there is a very popular method that is a 12 factors application, which actually defines if you can convert a business case into a micro front end or microservice. So for example, first is the code base. You can have a single code base and you want to split that in two different code bases. So that is one of the factors. Maybe there is dependency, there's configurations, backing services. Of course, there's build and release and run cycles that you want to build for a specific microservice. There are processes, there are like port bindings. Finally, there are concurrency, disposability, def prod parity, logs, admin processes. All of these factors accumulate and define if you can create a business case into a microservice. Otherwise, you can still add that as a feature in your existing application. So that's how you actually define if you have the capacity to create a microservice. So essentially, when you scale a micro frontend, you're gonna face 5 fundamental problems. I'm not gonna go through all of them, but I'm gonna go through one of them, which is templating. I'll explain the other 4, which is first of all, documentation. All of your teams, all of your working assignments, your colleagues are gonna work on something that is totally secluded from your work. And essentially, when you document your work, you need to figure out how you can scale while keeping them into the context of your application. Second is testing. When you have different applications, different architectures, different products, you need to have your own testing tools dedicated for that particular application. A React app should have React front-end library. Maybe Vue has something else. So you need to define what you're going to use for each application and keep that consistent throughout. Third is authentication. Authentication is always a difficult method. In edX, what we do is we have a service that sends us JSON tokens for each customer. We have that authentication microservice, and that serves all the micro frontends across. And every microservice or micro frontend just keeps the track of that authentication. Lastly, we have packages and plugins. You can define your own packages, your own plugins, and keep that reusable code available for everyone. So that's the whole idea of packages. Coming to the micro front-end templating, what it essentially means is how you can create a micro front template and use that to rapidly develop any front end for your application. So, for example, when you're adding a new micro front end, you need to realize what the business case is and how you can create every new micro front end for every new business use cases. Then there is rapid prototyping. Whenever you are trying to create a micro front end, you need to realize if it's easy to create and easy to develop, and it should be deployable in a matter of minutes. Then you need to have reusable code templates that can be utilized for your own application. For example, React is a good example. There's a Create React app, which is essentially a good template to start on. You can have your own reusable infrastructure templates. For example, in edX, we have that template where you can that actually creates a React template for us and creates all the folders for components and apps and database connections and everything. And finally, there are helpful project packages. So for example, there are stylings, there are configurations, there are themes and everything. You can all accumulate that into different NPM based packages and deploy that on NPM or maybe your own application. Use that as packages, node modules, rather than adding that as a code inside your application. Finally, we are here over the case study of OpenEdX and how we engineered our microfrontends. Starting off, we were one of the biggest, code bases in the whole world. We were the biggest monoliths in the whole world. And right about like in 2017, we decided that we're gonna divide it all in microservices and microfrontends. So first of all, we have IDAs, which are independently deployed applications. They're based out of Django applications. Initially, the monolith was Django application, serving the front end and back end simultaneously. Then we have microfrontends. These microfrontends are based out of React and Redux. Right now, we originally had about 2.5 million lines of code. Right now we have, accumulated that into 46 microservices, and it's now 0.7 million lines of code. So a huge difference between everything. So why we decided to build microservices? We have this whole document that we have kept a track of. Every time we think that we need to do something different than microfrontend, we go to that and we realize why we did that. So first is testing an MFE is extremely easy. You can just mock the REST API. We had a full scale Cypress based and Boxer based end-to-end testing framework, but it couldn't be deployed on the whole system for like almost 10 years, right? So it was a big problem for us whenever we had to create any change in the product. And yeah, when we shifted towards MFE, we just had to mock the REST API and we can do all the testing inside the REST framework and Jest and React testing libraries, stuff like that. Secondly, it was a very big mess originally, that we had a very big monolith and everything connected from front end and back end was tangled with each other. We decided that we're gonna create a monolith of our front end, right? but everything was so tangled and there was so many uh, interconnected parts that we essentially decided that we are gonna divide everything into micro frontends and connect those micro frontends using different gateways. Lastly, uh, not lastly, but the next thing was when we converted towards MFEs, our PR was deployable within an hour. So on this day, I can just create a PR, get a green build, and deploy it within an hour. It used to take us from 3 to 4 weeks, which is a huge time for any deployment. And we just hope that everything works. And right now, we can just deploy it and check it out in production under an hour. So yeah, that's a big change for us. Uh, then we have, of course, we had the backend logic tangled with the front end logic, and we wanted to refactor that, separate everything. Uh, we just, when we secluded front end and everything, we had the opportunity to decompose the monoliths into microservices, and that was a huge plus for us as well. And lastly, we just loved React whenever we work in it. And yeah, that's one of the reasons that we, decided to work in micro frontends. We just want to work in React. And yeah, what was the thought process? We had this very big meeting back in 2017 where we sat down and we started thinking like, what are we gonna do whenever we are gonna take the next step in the engineering part. And we came up with the three fundamental ideas. So first is decentralized beats centralized. We decided that we are not going to focus on monolith architectures anymore. We're going to focus on micro frontends and microservices. We're going to divide everything and keep every team secluded to increase collaboration rather than competition amongst the workers. Then we are going to build asynchronous application rather than synchronous, which essentially meant that we're going to ditch the synchronous behavior of Django, and we're gonna work on building something like asynchronous environment over React. And lastly, we are gonna focus on intentional architecture rather than emergent design, rather than seeing where it goes. So all of this combined to our decision of taking a microservice and micro frontend architectures. So essentially, we all, decided that all of this meant that we're gonna convert to a microservice and micro frontend architecture. Of course, the journey was super cool. We had this edX platform, a monolith. 10 years in making. We had LMS studio authentications. We had e-commerce modules, video modules, all combined with each other. Then we had some development challenges, which was like 2.5 million lines of code. Nobody had any context of what's happening. There were like long deployment times, which were like 2 to 4 hours. There were long deployment cycles, which were like 3 to 4 weeks, and there were no clear boundaries of ownership. Nobody knew everything, of course, and nobody knew what they were working on, and it was such a mess for us to work in. Finally, there were like scalability challenges. We saw that we couldn't build something new without breaking everything. Every application was tightly coupled. Performance was damaged. There were dependencies that we didn't want, and they were still there, affecting the whole application. We couldn't utilize real-time eventing. We wanted to focus on event bus and everything, so we couldn't utilize that. So all of that were like big scalability challenges that we eventually decided that we're gonna move towards microservice migrations. So to this day, all the front end architectures have been deployed into microfrontends. Right now, this is the whole architecture. This is what everything looks like. Right now, there's still a monolith which is called Redux platform that is serving some core APIs for the backends, and then we have IDAs, our backend services that is either connecting towards DBs or providing some sort of calculations, search algorithms, stuff like that. And we have our dedicated micro frontends. One thing I would like to mention over here is that we have dedicated micro frontends for each application for each client. So, for example, if we have a provider like GTX or like Georgia Tech or maybe MIT or Harvard, we provide dedicated micro frontends for each application for each provider. And that's a huge plus for us as well. These are all the references. If anyone wants to get any of these references, they can ask me directly on LinkedIn. You can reach Time Out, I believe. And yeah, that's all from my side. Thank you.